take a look. So you said number 1. All right, so number 1, just like every quadratic, or anything that we're trying to factor, forget about quadratic. We should first look to see if there's a greatest common factor, right? Because not all factoring is just done into 2 binomials. Okay, so what is the greatest common factor between 4 and -20? 4. So we know we have that greatest common factor. And then, is there an a in each term? Is there an a squared in each term? Yes. And then there's not an a to the 3rd power, right? So a squared is the biggest a that we can pull out of each term. So now we're going to pull out that a squared. Now, some people I saw yesterday, maybe, or the day before, were pulling out the number and forgetting about the variable. Sometimes that's the case, and sometimes that's all we can do. But we have to check. If there is a variable, a common variable in each one of the terms, then we have to pull that out too if we're factoring it. Does that make sense? So in this case, we want to pull out the greatest one. So just pulling out an a wouldn't be enough. It wouldn't be factored all the way. We would still be able to pull out an a squared, another a. So 4a squared is the greatest common factor. And then what's left is that distributive property in reverse, right? So 4a squared times what would give us 4a to the 4th? Just a squared. And then 4a squared times what would give us -20a squared? Just -5. So to me, once I determine the greatest common factor, it is easier to kind of work almost thinking in terms of the distributive property, but now we have to come up with what we had to multiply by to get to where we were going. Okay, so any other ones? 7. All right, so I'm glad you asked about 7. I'm actually going to try to do this on the board if I can. So let me turn the projector off. I think it would show up a little better on the Zoom. So 4b squared minus 324. And again, the directions are factor completely, right? So is there a common factor between 4 and 324? 4, right? So we're going to pull out the 4, and then we're going to go here. There is no b in this term, so we can't pull out another, or pull out a variable as well. So 4 is the only thing we can pull out. So what are we going to multiply that to get b squared, or 4b squared? B squared, right? What are we going to multiply 4 by to get -324? -81. Now, the directions are factor completely. So whatever's left, we have to think about, can we factor still? And a lot of the time, the answer is no, I'm done, just like the first one we just did. But now, what do you recognize about b squared minus 81? I can hear some mumbling, but I can't really hear what anybody's saying. What is true about both of those terms, b squared and 81? They are both what? Well, 1 is the only number that, well, 1 goes into them. Well, let me ask you this. Is b squared a perfect square? Multiply something by itself to get 81. So are they both perfect squares? Yes. And do we have subtraction? So remember, we discussed that one special case where I said it's very beneficial to remember, and this is probably the first time we've seen it going in the opposite direction. Anytime we have the difference of 2 squares there, remember, it can break up to, let's just say, a squared minus b squared, when those two things are perfect squares. they can break up to be a plus b and a minus b. Remember? And really the only way we looked at it before was when we were multiplying and we were trying to FOIL stuff out and that outer and inner term went away. So since 81 is a perfect square, since b squared is a perfect square, we can go ahead and say that that's the difference of two squares, and we can help with our factoring. So since that number we pulled out is already out there, we're going to carry him along, and then we're going to break up this into b plus 9 and b minus 9. Okay, so the difference of two squares, that to me is the place where we're going to use that the most, where it's going to be the most helpful, because A, we can see that, so it's kind of easy to identify, and then B, it's also super easy to go ahead and factor apart once we get the hang of that, and we'll do more of those in the future. Any other questions? No. So the factoring for that part is okay. All right, well, we're going to start today and looking in the continuing of the factoring, where remember we said all of these can be all written in a general term of ax squared plus bx plus c, right? So today we're going to look at factoring when a is something different than 1, when it's bigger than 1. Okay, so there's a number in front of the x squared this time. Okay, and it doesn't change a whole lot, but it has to change the way we think. Okay, and if we start with something pretty easy, so all of my rules for the signs still apply. Okay, if this is positive, then we're going to have the same sign. And then all we have to do is look over here and see which one we're going to use, right? If that's negative, we're going to have different signs. And then we still have to look over here to figure out, when I combine my like terms, what do I need that outcome to be? Is it going to be positive or negative in this case? So just by looking at this one, C is what? Positive or negative? It's positive. So my signs are both going to be the same, and what are they going to be? Positive, right? So we know that that rule still applies. Now, if we think in FOIL, in terms of somebody multiplied these two things together and got this, right? How could we get 2x squared? Two times what gives you 2? 2 times 1, and we don't have to write that one, but I'm going to on this one. And then how do I get x squared? X times x. So the only way that we can get 2x squared is if I multiply 2x times x. When somebody did the first part of FOIL, right? Everybody with me? So nothing's changed there. Now, what numbers multiply to give us 10? Because somebody has to multiply these two numbers together in that last step for the L and get 10. What are the numbers? 5 and 2 and 10 and 1. Now, what we've done before is say, well, because this is plus, we're going to add together to get 9. Do either one of those numbers add together to give you 9? No. So now what we have to do is we have to think, well, when we multiply outer and inner, isn't somebody going to multiply, or aren't we going to multiply 2 times this number for the outer? So that 2 in front now changes it. So we're no longer just thinking about 5 and 2 and 10 and 1. We have to think about that 2 and then this 1 multiplying by these numbers and giving us the correct combination to get 9. Okay, and they call the way I'm going to show you right now guess and check, but it's not always just a true guess and check. And we're not just randomly plugging in numbers, okay? We're going to become better at this and start using our brain to make more of an educated, I guess it's still a guess, but we're going to use some knowledge to guess wisely instead of just randomly plugging in a number. All right, so let's think about this. 10 and 1. And I'm going to do it out with you so you can see what I'm thinking in my head, okay? So let's just say we don't know because this is the very first one we're doing, and you just randomly plug 10 and 1 in here, right? So we know that these two things are going to be correct, right? This is what we talked about the other day. We picked the number specifically to give us 2x squared, and we picked the number specifically to give us 10. All we care about is making sure that this is the correct number. So outer and inner are the parts that we're concerned with, right? So what do we get when we do the outer? 2x. The inner, 10x. And that gives us 12x. Can we think ahead and say, well, then, you know, the 2 times the number is what we need to figure out, combined with the 1 times the number, and it's going to give us 9. And that's what we're working toward. All right. So that's what I was just kind of showing you. What if we screwed this up? What would it look like? But you're exactly right, that, you know, we can think, and that's what I was meaning, like an educated guess. So if we flip-flop that, would it be right? So just you know, just showing you how I would screw this up, just in case we see, what's 2 times 10? 20, and then 1, that gives us 21. Still way away from that, right? So could we think, well, we need to get 9. So what about these? What if I doubled 5? That's going to give us 10 is too much. What if I double 2? That gives us 4, and then the 1 times there. So that's what I mean when I say we're going to use our brains instead of just blindly guessing. Okay? And the question on Zoom was exactly right. That's what I want you guys to do. I want us to think ahead, but I was just showing kind of the process that you might go through in your head. All right? So now let's double check our work. 2x times 2 gives us 4x. 5 times x gives us 5x, and together that's that 9x that we were looking for there in the middle. So all of our rules still apply that we talked about on the first couple of days of factoring. And one of the things that I didn't say at the very beginning of this problem was what we should have looked for, and I don't do a good job of remembering to say that every time. Is there a greatest common factor here? Like before we even got started, was there a number between 2, 9, and 10 that is common? No. But you have to make sure we look for that to start. Okay? And I'll do a better job of saying that out loud and making sure that we do that, because you need to get in the habit of that. So any questions over the very first one that we did where A is greater than 1? All right, so let's try another one together. Let's try 5x squared plus 31x plus 6. We'll do this one together, and then I'll let you guys try the next one on your own. What is the only way to get 5x squared? 5x and 1x. So what are my signs telling me? They're both going to be plus, right? Signs are going to be the same because that one's positive, and then that one tells us which one we're going to use for both of the binomials. So now off to the side, what numbers multiply to give us 6? 3 and 2, and 6 and 1. So we need to be 30. So think about that 5, right? We're going to multiply one of these numbers times 5 and the other one times 1. Which combination can we multiply 1 by 5 and the other one by 1 and get 31? The 6 and the 1, right? But which one does the 5 have to multiply by? The 6. Everybody see that? Because now we have 30x and then 1x combined give us that 31x that we're looking for. So perfect example of that was not a guess and check, right? You guys used your brain to realize that the combination, we're just going to multiply something times 5 and then the other one by 1. Now, what do you notice about the numbers that I've given you for the A spot so far in the first 2 examples? They're simple. How could we categorize that number where there's only one way to multiply to get it? You know what that's called? Starts with a P. They are prime numbers, right? I hadn't heard that term in a while. A prime number means that the only factors of the number are itself and 1. No other number goes into them. So it makes it pretty easy to start with those kind of numbers as an example, right? So, you know, if it's not a prime number, or this one I've given you where it's got a couple factors, but what if we have something like 24 at the end, right? 24 has a lot of factors that would pair together to give it that total, that product. But the process is no different. It's just a little more tedious. And that's when this can become a little bit of a pain, but it's still not something that we can't figure out by putting a little thought into it. All right, let's try this one. Or you try this one. 3x squared minus 14x minus 24. Put your mask up. So this one is a little different, right? Because I added a little bit more of a few choices in adding and doing the 24. And then what else is different about this problem? I got the 2 negative signs. Well, really, this one's the only one we care about to begin with, right? That means that they're going to be different. But the rules still apply. So see if we can figure it out. Yes, but let me address that question in just a second and give everybody a couple more minutes, because that's exactly what I wanted to talk about. Excuse me. All right, so let's go ahead and get started. So how many people thought to check to see if there's a greatest common factor? 2, 3-ish? Not. All right, so we need to get in that habit, okay? And again, I'm going to do a better job of reminding us. Is there one? No. So how do I get the 3x squared? 3x and 1x, right? Signs are different. And then what we used to say before was the bigger number had to have this sign, right? But now the bigger number that when we pick our factors may not be the one that's bigger here. It has to be the bigger number after we multiply. So the bigger product in this case has to be negative, okay? Because we're going to change. It's not just going to be the 8 and the 3 that we pick, or the 6 and the 4, whatever it is from this number. It has to be the bigger one after I multiply it by the 3 and then that one by the 1. That one has to be the bigger of the two signs, so that one would be negative in this case. So we can't even put our negative and plus in yet. So what we got? 12 and 2, 24 and 1, 8 and 3, 6 and 4. Right? So there's a lot of choices this time. We need to get to 14, and we're multiplying one of them by 3. And this time we are subtracting to get to 14, right? Because the signs are different. So which one did you guys find? 6 and 4. So thinking through it, if I multiply the 3 times what? The 6, then I get 18. And then take away 4 gives me 14, right? So I need the bigger product to be negative. So if I'm multiplying 3 times 6 and that's 18, that has to be the bigger product, right? 18 is going to be bigger than 4 times 1. So that has to be negative. It has to have that same sign as B. And then this one will be plus, and we're picking it to go with 4. So how can we check our work? We can FOIL it back out. Do we need to FOIL the entire thing? No, because for the 1000th time I've said it, and you're tired of me saying it, we picked the numbers to be 3x squared. We picked the numbers to be 24, negative 24. So we know that those two parts are going to be right. So really all we need to check are the outer and inner. 3x times negative 6, negative 18x, and then plus 4x gives us that negative 14x that we needed. Okay. So I was going to try, I have these written out, and I was going to try to share the screen with the Zoom call, but I just don't think it shows up very well. So I'm going to put them up here, and then we're going to try these, and then we're going to come together and work them out. So 3x squared plus 2x minus 8. And the second one is 4x squared minus 14x minus 30. What do you notice about number 2 that's different than what we've done so far? Four is not a what? It's not a prime number. 3, 3x squared plus 16x plus 5, and then number 4, 4x squared plus 30x minus 16. So make sure that each one of these, you check for a greatest common factor. If it does have a greatest common factor, we'll pull it out, we'll factor it out, and then start over. See what's left and see if we can continue to factor from there. So just another couple seconds and we'll get started going over these. You guys got them? So we'll start with 1, and if you're not all the way finished yet, then we can kind of slow down toward the end and let you get caught up. But let's check the first one. So, is there a greatest common factor? No, 3, 2, and 8 do not have a number that is a common factor besides 1. So we know we can go ahead and say 3x and x. Now 8. How many different factors of 8 are there? 8 and 1 and 4 and 2, right? So now we're looking for a combination that will subtract and give us 2 after we multiply one of them by 3. So what did you guys figure out? 4 and 2, because if we multiply 3 times 2, that gives us 6, and then we take away 4, we're left with 2. We need the bigger product when we multiply 3 times 2 and 4 times 1. The bigger one has to be positive. Which one ends up being positive? 3 times 2 or 4 times 1? 3 times 2. So we're going to say plus 2 to make that positive 6, and then minus 4 to give us negative 4. Right? So if we're checking our work, the outer term is negative 6, or excuse me, positive 6x, and the inner term, what's that? In this class? Okay. Right now? She's starting, I mean, like she's coming in right now? Okay. Come on in. Hi. You can have a seat in that last row, maybe? Which class are you coming from? Okay. So are you brand new to the school? Okay. All right, have a seat, and then we'll get you caught up in just a minute. And then what is the inner terms? Negative 4x, so that gives me positive 2x, right? And that's what we wanted. Any questions over number 1? Number 2, is there a greatest common factor? Yes. What? 2. So we're left with 2x squared minus 7x minus 15. So were you able to factor it from there? Can we factor it from there? So let's try it. I'm going to move it up because I'm running out of room. I can't write right there. So we'll move it right here. So right now what we're working with is 2x squared minus 7x minus 15. So let's see if we can factor it. 2x and x. Are there numbers that multiply to give us 15 that will combine here to give us 7? What are the factors of 7 or 15? Excuse me. 15 and 1, and then 3 and 5, and that's it, right? So we need them to subtract to give us negative 7. So what did you find out? Do any of them work? Which one? 3 and 5. So we get 10 minus 3 gives us 10 minus 3 gives us that 7, right? Is 10 or 3 bigger when I multiply them together? The 10, right? So I need the 10 product to be negative. So negative 5 times 2x will give us that negative 10x. And then plus 3 here will give us that answer. Did anyone try to factor from the beginning without pulling out the greatest common factor? I thought I saw some when I walked around. What did you end up with? But before that, what did you get? 4x plus 6, x minus 5. Does that work? Did you check your answer and it went back to the original thing here, or polynomial? Yeah, it works. But the directions say to do what? Factor completely, right? And that's what they're going to say. Is this binomial factored completely? No. So now, if we wanted to, we could see that this guy right here has a common factor of 2. So we could pull him out. And then we would be right back to where we were right here, right? So the greatest common factor at the beginning does a couple things for us. Number one, if there is one, it helps us to work with a lot smaller numbers. But also sometimes it is the only thing that we can do. So that's why it's important for us to check from the beginning. Okay. All right. So sorry, I bunched all that up. Trying to fit in the window that's being shown on the computer so we can all see it. All right. So now this one, is there a greatest common factor? No. 3x and x. And then what do we know about 5? It is also prime, right? So this one, probably the easiest one I have on the board. Signs are the same. They're both plus. And I need them to be 16. So where am I going to put the 5? Right here. And then the 1 goes there. Check out our outer and inner terms. We get 15 and 1. Give us the positive 16 that we were needing, right? So maybe you should have started with that one since that was the easiest one, but still works. And then last, is there a greatest common factor? 2. But if you didn't have it written down or didn't do that at the beginning, can you take it out at the end if you were able to see it that it was factored? And you should have been able to, I think. So what's left here? 2x squared plus 15x minus 8, right? After I factor out that 2. Now, can that be broken down a little more into 2 binomials? 2x and x. Signs are going to be different. What are the factors of 8? 4 and 2 and 8 and 1, right? So is there a way that I can combine that with 2 being multiplied into one of them and having their difference be positive 15? So I think of 2 times 8 being 16. And if I take away that 1, that gives us to that 15 that we need, right? So the 2 and the 8 have to go together. And then the 1 and the 1 have to go together. And then I need my bigger product to be positive. So which one is it? With the 8, right? And then minus 1 there. So we could check our work. And then that is the correct answer. If you did not pull out the greatest common factor at the beginning, can you now? Yeah, if you saw it at the end, right? So make sure that we have that factored out. So this would be that trinomial factored completely. Okay, so what we have for practice is a Delta Math assignment. And then I also gave a quizzes exit ticket. Now the exit ticket for the people who are in class, we'll finish up with that tomorrow at the end of class. It'll be a short class tomorrow. because it's not a block day. The distance learners can do that just before then. So if they wanted to do it right now and get it over with, they can and be finished up. But here's what we have coming up. We will have next week in advanced honors, we will have a quiz over factoring. And then after we're able to do that, then we will have a test. Now the test for the distance learners will be on an online platform. Still trying to figure out what will be best for me there or for us. And I think what I'm going to try to do for the in-person learners is give you a traditional paper test. All right. So we don't have devices in class. So I don't think it's very fair to make you have to do it on your phone. So are there any questions from Zoom? Are there any other questions from in class before we start working on that Delta Math assignment? So everybody's good? Both places? Oh, I see the question here on the chat. Okay, so you're good now? Okay, perfect. All right, well, please let me know if there's any other questions, and if you need an individual Zoom, we can do that as well to help.